Hi, Marek.
I know.
Too bad. Hi, Jason. Hello, Jason. Yeah. So I open up.
Hello, am I in?
Yeah, you are, Jason. You're grand.
Yeah, excellent. How are you?
Not too bad now at all. Survived.
Oh, I had a day off there.
Sorry?
Oh, I had a day off there.
No. Just I had to figure out something here. I hadn't figured out myself, so.
Oh yeah, no worries.
No real big. No. There'll be no days off. Can't escape. Morning, Iggy. Morning, Brian.
Good morning.
Morning, Iggy. How are you doing? Good morning, Thomas. Good morning, folks. Now, we're going to be using the command line prompt today, God help us. But yeah, just you can talk amongst yourselves there. I just need to go make myself a cup of tea. Okay?
A quick question there, no. Just
Yeah. Good morning,
can you hear
Priya.
me?
Yeah, I can hear you, Iggy. Yeah. Yeah, Iggy, go
Just
on.
a quick question. I think 8.3D. I was having an issue there with getting to view it. 8.3D.
Oh, video.
Yes, I don't know if anyone else had or you
Let me
might have a look
at
at it at some point. It maybe.
No, I'll have a look at it now this minute. Let me just see.
It might have been my side because my internet is bad, you know.
No, it's okay, Iggy. I'll have a look. 8.3D. Now, I think we want so yesterday or now.
We forgot to record some bit of coding and all.
All right.
Some bit of coding we didn't record. Some part of 8.3, I think.
8.3 seems to be okay here, Iggy. What I'll do is I'll recode it again and I'll put it up. Is that okay? Is that okay, Iggy?
That's perfect. It just didn't seem to. Yeah, that's perfect.
Yeah.
Thanks, no.
Did anyone else have a problem with 8.3D? No one else had a problem with 8.3D? No?
Which one?
No. Okay. All right. What I'll do, Iggy, I'll try and recode it again and see. Okay? Yeah. Give yourself 2 minutes there, folks. I'm respecting 2 minutes. 2 minutes there, please.
Hold on, see.
Томаш.
Привет, how are you?
Привет. Нормально. А ты?
Все хорошо.
Хорошо?
Угу. Да.
Хорошо, значит хорошо. Как собака?
Что?
Very good. Good.
Okay, folks. Morning again. Okay. So good morning, everyone there. And
Morning.
morning. So what I'm going to do, I am going to start. All right. Now, so it was here. So I'm going to start here. So we were doing serialization. Okay. And 8.3c was the last thing we did. Okay, so we have it here. All right. So let's go back to here. Right. So what serialization is, it's saving an object of a file or object of a class as a file. Okay. So if done properly, can save your whole application as a file. All right.
I know.
Oh, good morning, Kieran. Okay.
Yeah.
So, as I said, you don't have to turn on your webcams or anything like that. It's just me that's going to be here, so that's fine. You don't have to turn on your webcams. Okay. Now, So just to go back over the stuff we've done already. I created a simple humans class, human like this here. Human implements serializable. Someone tried to ring me there. Okay. Public class human implements serializable. So these are all serializable. You make something transient, that means it's not going to be serialized. Cat is a, so when you implement serializable, that means you can serialize it, that you can use something called an object output stream, right? When you're serializing a object of a class, it uses the object output stream, and when you're deserializing, it's using the object input stream. Okay. Now, I'm gonna serialize it here. So I create a new human. So then I go try block file output stream is equal to file out new file output stream, and object output stream is equal to new object output stream. Okay, so this guy produces bytes, then so you put that in there, and this produces a serialized object that's going to be saved in the file. Okay, so far so good. Then we went down to school, and we created a school. We go creating the school. My school is equal to new school. And if we have a look at the school class is made up of a name, a start time, a static encounter, a school ID, a private static final local date right now. So this can be used to uniquely identify a serialized file, local date, time ID, set teacher. So a school is going to have a set of teachers, a school is going to have a set of pupils. Okay, now if you mark, so janitor is not serializable, so we mark janitor as being transient. So in a class, if you have a variable that's marked as transient, or if a variable that's marked as static, both of those will not be serialized. Now, so we have transient, janitor, my janitor, you can also mark a class that does implement serializable, for instance, teacher. So these two will not be serialized in the class. Okay, so we created blah, blah, blah. Then I go here. So I create a school object, I call it my school. We can see that the school has a janitor. Then we create our output file, then try. So what I do here is I create a file output stream, my file, and this creates an object output stream, which creates the file, which will be called output.data, which is this guy here. So it's all this kind of rubbish, okay? Now, so I write it, I close it after serialization, before serialization. Then to deserialize something, we use file input stream. Okay, so this will get the data level, this will convert it into objects. If I want, so then I go in.read object, in.read object, so our object, output stream object is called in.read object will return an object reference to the school. Sorry, an object reference to the school object, okay, which is output.data, which was my school. So then I cast it to be a school. So new school and my school are going to be copies of each other, but they're not the same object, okay? To prove that they're not the same object, I go my school equals new school, that returns false, okay? Now, the original school had a janitor, all right? Now, but the janitor was marked as being transient, which means it's not serialized. So now this guy here is a copy of this guy with a couple of exceptions, okay? It's not the same object, number one. Number two, any of the transient variables of the school class are not going to exist in this guy here. So my janitor is going to be null in this guy. Is everyone okay with that? Is everyone okay with that?
Yeah.
Yes.
Yeah.
Yes.
Okay, right. Now, then we went on to creating serialized classes. or our serialized our methods that's going to serialize the object. Okay, so I go school, my school is equal to new school, system println my school is my school. School janitor is my school janitor. So then I have a method called serialize me. Okay. Put this right here. Okay. So serialize me. Now what we're going to do here is we're going to generate an automatic class, and just to show you how it works, main examples.ex3. Okay, so, and if I refresh this guy here, refresh, see the new file has been created there. I'll run it again the next time, and we'll see there's 2 files. Refresh it. We now see we have 3 files created. Okay, so each time we're doing this, we're creating a serialized file that's going to be the school, that's going to be an object of the school class. It's going to be a school. So each one of these here is an individual school that has everything except a janitor and any of the statics of the school class. So each of these guys here, it's going to have a name, it's going to have a start, it's not going to have a counter, it is going to have a school ID, it's not going to have this guy, it is going to have this guy, it is going to have this guy, it is going to have that, it is going to have that, it is going to have that, it's not going to have a janitor. That variable will be set to null. It is not going to have a headmaster, all right? But it's going to have everything else, all right? Now, so each time I run it, it's basically creating a copy of this one with exception. It's not going to have the same, it's not going to have the statics, and it's not going to have any of the transient variables, specifically the janitor class. Yes? Is that okay with everyone?
Yeah.
Yeah, right. Now, so we can see the 3 of them I've created there. Now, if I serialize something, you have to be able to deserialize it. So you can imagine you're doing your app is working away. At the end of the day, it saves all the work you've done during the day as a serialized file. Okay, you are doing work, logged in under a certain name. All the work you have done is saved under your profile name, and it's going to be saved as a serialized file. So at the end of the day, it runs a file, it runs a method called, so before you shut down, what happens is it runs a method called serialize me, and it saves all your work as an object. It saves all your work as a serialized object, which can be saved as a file. Okay, so these files contain all your work that you've done during the day, so you lose nothing. So you start your app again, doing whatever work it is on your app. So your app, let's say it's Microsoft 365. When you click on Microsoft 365, it opens it up, but the first thing it does is it deserializes the file you've been using yesterday. Okay, so this is going to serialize it. Now, what does the serializing do? Now, we want to give a unique name to the file. So one fairly simple way to give a unique name to anything is to get the amount of nanoseconds in the current time, okay, in the current hour, or the nanoseconds in the current second. When we get time, if we go local time dot now, that's going to give us time to the nanos. So if I go long nanoseconds local time dot now dot get nano, that's going to get the time in the current second. So we can see here, for instance, this is 0.887, and that will be 6 zeros. That's the current nanosecond part of the current time. So does everyone understand what that's doing there? Yes?
Yeah.
Yeah?
Yes. Yes.
Yeah,
Okay.
yeah.
Right. And it's not the amount of nanoseconds since midnight, it's the amount of nanoseconds in current second is nanoseconds. Okay? So serialize me. So amount of nanoseconds since midnight is 887 million. All right, 887 million. Okay, so then our file is serialized. So I'm going to give our file a name. It's going to consist of the words backup, followed by nanoseconds, followed by the name backup.data. So we can see here, amount of nanoseconds, it's not since midnight. I'll run it once more, and I'll refresh it here. So we have a new file called backup773 and all those zeros. Okay, so the name of our file is 773 and 6 zeros. We serialized our file. So what happens here is, now we're using a try with resources. So we need to use a file output stream and object output stream. This deals with the bytes. This turns the bytes into an object that is written out to a file. Okay, so this is what actually writes the school object to the file. So out.write object my school, and the name of the file is plus name. So the name of the file is backup 773 and 6 zeros. All right, and there it's serialized. So our file is created. Is everyone okay with that so far? Yeah?
Yes.
Yeah, okay. Now we are going to do deserialization. The next one. All right. So I'm going to go here. So we have static void serialize me. We're going to have static void deserialize me. Okay. Now, so instead of sending so with serialize me, it takes a school. Now deserialize me takes a file, and it's going to deserialize it. I'll call this file name. Okay. So we're inside it here. Now, so this is going to return as well. It's going to return a school. All right. So serializing returns void, but it creates this file. Okay. Deserializing takes one of these files and it returns the school. So it's just the opposite process. Okay. So inside here, I'm going to go school, my school. Okay. So what is this object? This is the school that will be created from the deserialized file. Okay. Now, so from this point onwards, when I'm using any sort of or inputs or outputs, I'm going to use a try with resources because they're just better. Okay. So I'm going to go try resources is quite simply just to try with a parameter list. Okay, so try catch exception A. Okay, so we are going to put in our two resources here that we're going to. So we need one resource that deals with file input stream file in is equal to new file input stream file name, and we go object input stream in is equal to new object stream file. Okay, that's fine. All right, so we're going to return this object. So what we're going to do is we're going to do here, we're inside the try resources. So we're going to say my school is equal to, now we can go in dot read object. Okay, now this guy here is an object reference to a school object. All right, so that means, and this is a school. Now we can cast it to be a school because it is at the end of the day a school object. So we can change the reference and it'll work fine. Okay, so school. So and what we're going to do with that, we are going to return my school. Okay, now inside here, and we'll just print off the exception. Now, problem with this here is that if an exception is generated, this is going. So, reason we're getting an error here is because no matter what, it has to return an object. Okay, it has to return a school object. Now, so if it does not manage to read the object, if this, any sort of exception is generated, this guy is going to catch it and it's going to return null. So what we also need to put in is return null. So this will return the deserialized object, the deserialized school object. Okay, now if suppose here, if the file is not deserialized and no object is produced, we get an exception. We have to return null. So if no school object is produced, null. So is everyone with me so far? Yes? Is everyone with me so far? Yeah?
Yeah.
Yeah, all right, so I'm going to go up here. So I'm just making sure I have this correct. Right. Now, so what we're going to do is each time we create a serialized file, we're going to deserialize the file. All right. Now, so right, I'm going to take the name of a file here. This one here. Okay. So that's the name of one serialized file, and you'll have to do the same. You'll have a different serialized file name. All right. Because the odds of us getting the same name are millions to one. Now, there is a possibility if you're creating millions of files, if you're creating hundreds of millions of files, then there is a possibility you're going to get two files of the same name. You can't have two files of the same name. Now, what you can have done there is, if you have two files of the same name when you're serializing, for instance, here, those files would not be created. So what you could do, so inside here, now it is possible, now the odds are very long, but it is possible you can create two files. So you could have two files of the same name. Now, you will not be able to create two files of the same name. So what you could have in there is inside the catch block here, you could create another backup file. All right. So this current way we have of creating files, it is possible to get two files with the same name. All right. Now, no operating system will allow you to have two files with the same name. So what you could do is you have a piece of code in here that's going to maybe just call it backup the number with 2. Have you ever seen in Windows when you try to, if you copy and paste two files with the same names, have you seen do you know what's done? Let me just show you. All right. So let's just go to, for instance, my Google Drive here. All right. And I am going to go to 2019, 2020. Okay, so this is some of our stuff here. And I have a chapter, or I have this, let's say this file here, which is, I'll take this one here, Java threads and concurrency utilities. All right, so if I paste that into there, it gives us a name like that, Java threads and concurrency. Great. So if I paste it in the second time, oh, fuck. Right, there's a new update. Now, normally what should have happened there is if you try to copy in a file of the same name, it will call it Java threads and concurrency utilities, put a little bracket and put 2 at the end of it. All right, so we could have code inside here in the catch block that does the exact same thing. If 2 files of the same name, now I can't remember the actual exception. There is a particular exception if 2 files have the same name. I can't remember what it is. So you could have another catch block there that would catch that particular exception. If it sees 2 files of the same name, it just creates another file. Is everyone okay with that?
Isn't it just easier to use timestamp?
Our timestamp. Yeah, but you see with the timestamp, it is possible to end up with.
No, if you use dates and times,
If you use dates and times.
it's not really.
Yeah, you can do that as well. Okay, but I don't want to put in dates. But yeah, we can do that as well, Igor. Okay. Now, so we can serialize something. Now, to deserialize something, we ideally need the name of the file. Okay, so I'm going to take this one here. All right, so I am going to create a new school. And I'm going to call it new school. Is equal to deserialize me. And what I'm going to pass into it is, now I'm going to use a string instead. Okay, instead of a file. Okay, so I'm going to use the string file name, which is going to be that guy. Now, that's the last file that's been created for me. Okay, that's the very last file that's been created. So I don't want to serialize again. All right, so that's the last file that was created for me. And if I go new okay, so there is our new school. Okay, there is our new school. Now it's a copy. But one thing it doesn't have is I go here, so dot janitor. It's null. Okay, so this school does not have a janitor. Is everyone okay with that? Yes?
Yep.
Now, this is a totally separate school, different. Okay, now I haven't serialized it. All right, so serialize my school, that would create a new file. Now, there is an issue with, well, it's not an issue with serialization. So you have to make sure that you are deserializing the correct file. Now, as you can see here, create a few more, run it a few times. So I'll run it 4 or 5 times I click on refresh here, new, click on here, refresh. You see we've created whole new files here, all right? Now, as I said to you before, you don't do constant serialization. Usually what you do is when you're closing down your app, you're going to have a serialized file that contains all of the relevant data. And then at the start of the next time you use the application, it loads up all the values in serialized files. Okay, it's not doing constant reading and writing in the background. It's just, it might be serializing every 10, 15 minutes itself, all right? But ideally, you'd imagine that you're about to close down you're working on Microsoft Word, you close it down, it automatically saves all of your work to a serialized file. Yes? Does everyone understand that?
Yeah.
Yeah. So every time we shut down our app, what's actually happening is that, right? It's serializing. Now, when we start up our app again, it's going to deserialize the last file you've used. Yeah? Yes?
Yeah.
Yeah. Now, what you have to make sure is that it's deserializing the correct file. All right? So you need to have some means of ensuring that it's deserializing the correct file, number one. Number two, that the file hasn't been tampered with in any way. That someone else didn't come in and change all your settings. Okay? That a hacker didn't come in and change all your work. Or someone else could have done it innocently, logged on, start doing all sorts of work. All right? So you want to make sure that you're deserializing the correct file. An example, I have a Word document, I have typed up 50,000 pages. All right? Someone else comes in and deletes 49,000 of those pages. All right? They log off. Now, so I do all my work on a Monday. Someone comes in on a Tuesday and deletes 49,000 of those pages. All right? So I log on Wednesday morning. I don't want to get Tuesday's work. I want to get Monday's work. So I have to make sure that I'm deserializing the correct file. Yes?
Yeah.
Yeah. Right. So what you need to do, you need to have some form of uniquely identifying a serialized file. All right. Now, there are a number of ways I've done them. Now, I have a more complicated example here, but I'm not going to show you that yet because it's so complicated. I haven't fully figured it out myself. All right. But so what I'm going to do is I am going to do a much simpler file. All right. I'm going to show you how to check to see if it's the correct file name or to see if it's the correct file you're deserializing. All right. Now, so I am going to create a new, go here. I'm going to go 8.3D. Okay, so new Java project. I'm going to go 8.3D. And I'm going to go finish. Oh, sorry, and that is 8.3 working, so I'll change that. Rename, so it is F8.3D, and this is going to be working with streams. Okay, now I'm going to go new, I'm going to go package, Android. Now I'm going to do new, I'm going to do class, I'm going to do main. I'm going to do class, and I'm going to do examples. Right. Now, I'm going to do one other class. I'm going to create a class called human. All right. Now, I am going to I'm going to give the human an age, a name. I'm going to give him a weight. And by the way, it implements serializable, obviously. And we import serializable. Okay, so int age, string name, double weight, and I am going to put in an inner enum, and I'm going to call this career or job. So the enum, it can only be either a doctor, nurse, a teacher, or a priest. No, doctor, nurse, or teacher. Okay. Now, and I'll make that. So I'm going to create a human class here, human constructor. It takes in an age, takes in a name, takes in a string name, and it takes in a job. Okay, and I go here as well, job, my job. J. So I go this dot age is equal to age, this dot name is equal to name, this dot weight is equal to weight, this dot job, this dot my job is equal to my job. Now, I am going to create now all of these are serializable. Okay, so enums are serializable. All primitives are serializable. Let me just make sure that, hold on a minute now. Okay, so it doesn't, so I just put it in there. Enum job implements serializable. Certainly that's serializable itself. All right. Now, so I have, here's our class. Now, is there any way to uniquely identify a human? How do you uniquely identify a human? How do you uniquely identify? What's the ideal way to uniquely identify anything?
Email.
All right.
Email.
No,
Static ID. Static ID.
yeah, but what method can we use to uniquely identify? There's a method. Which one is it?
Equals or hash code?
Hash code.
Hash code.
Okay. So I'm going to create now. This is one way of doing it. It probably isn't the optimum way to do it, but it's the easiest way to show you. Okay. So I'll go to source. Now, I don't know if this is on the exam. I can't remember if it is. I don't think it is, but this is something you do need to know practically. You have to know how to uniquely identify a file. You have to know then how to deserialize the file that you want. Okay. One way you can uniquely identify something is by using hash code and equals. So I'm going to use age, my job, name, and weight. I don't have any statics in it. All right. Now, so here we have equals, and here we have hash code. All right. Now, so I'm going to go here to examples. Static void ex1. All right. And let's go to human as well. I'm going to create a toString method, source, generate toString, generate. Great. Everything's hunky dory. Right. Now, I'm going to create a human. So I'm going to pass it in an age, 34. I'm going to pass it in a name of Andy. I'm going to give it a weight of 78.86, and I'm going job dot doctor. I'm going to create another human. My human 2 is equal to new human. I'm going to make this 48. This is going to be Helen. Her weight is going to be 56.78. Job is also going to be a doctor. And I'll create two more. Human, my human 2 is equal to new human. I'm going to give this human an age of 22. This is going to be Sean. Sean is going to be 67.89, and his job is going to be a nurse.
Noel,
Yeah.
you've used the same my human. You're changing there now. Yeah.
Thanks, Kieran. Okay. So human, my human 4 is equal to new human. This human is going to be 56. This human is going to be called Siobhan. And this human is going to weigh 51.22. Job is going to be teacher. Right. So there's our 4 human objects. Now, we're going to have a method that is going to serialize. Let's make sure I have it right here. So serializing is the easy part. Okay? It's deserializing that's the problem. Okay? So this is going to be a method to serialize a human object. Okay? So, as I said, serializing is fine. Nothing static, void, serialize me. And what are we going to do? We're going to send it a human, or serialize human. Okay? So I'm going to send it human, my human. Now I'm going to use the same process again. I'm going to go long nano seconds is equal to local time now dot get nano. Okay. Right, so that's just going to get us the nanoseconds. All right, and I always want to see what the nanoseconds are, so I'm going to say nanoseconds is plus nanoseconds. All right, so I am going to the name of our file, so string file name is equal to, I'm going to call it backup, and I'm going to say, oops, plus nanoseconds plus, I'll make this shorter this time, I go dot data. Okay, so that's going to be the name of it. Now, then we're going to do our actual serialization process. So I'm going to have a try block with the parameter list. And I'm going to catch it. Here. Now, so I am going to go here. I have file output stream file out is equal to new file out stream, and it's going to be file name. So I'll import that guy. And then, so that's for dealing with the streams, for bytes, I mean. And this is for converting those bytes into objects. Object out. Stream out is equal to new object output stream file out. There. And change to object output stream. All right. Now, so inside here, we're going to write to the file. So I'm going to go out dot write object, and we're going to say, hold on a minute, I don't something around there. My human. Okay, so, and then we don't need to close it, we don't need to flush it because it's done automatically. All right, so now I'm going to serialize each one of these. Right, I'm going to serialize each one of these. Now, what I'm actually going to do is as well, I'm going to change this slightly. All right, I'm going to take the name of the human and make that part of the name. All right, so I'm going to change back up here. What I'm going to put in instead is my human dot name. Okay, so we'll have Andy plus how many nanoseconds data. We'll have Helen plus how many nanoseconds data. We'll have Sean plus how many nanoseconds data. We'll have Siobhan plus how many nanoseconds data. Yes? Yes?
Yep.
Yeah, so the serialized file will be made up of the human's name plus the nanoseconds in the current second. Right. Now, I'm going to serialize the first human. So I'm going to go serialize serialize human. I'm going to say my human. Okay, so I'm going to run. So I'm going to go to main. I'm going to go to human. I'm going to go to here. So I'm going to refresh it here. There it is. ND has been serialized. All right. I don't want to serialize ND again. So I'm just going to do one for each one of them. So serialize human, my human 2. Now this should serialize Helen. So nanoseconds is 9 million. So we refresh this. We'll see we've Helen. Now I'm not going to run them a second time because I don't want to create a second Helen. I don't want to create a second anti-serialized. Okay. So we go RILSE, my human 3. So refresh here. We're going to see Sean. And the last one then. refresh this. Okay, so serialize human, my human. So now we have our 4 files. We have Andy, we have Helen, we have Sean, we have Siobhan. Yes? Yeah, whoever that is, I can't hear you. I can't hear you. So there was something wrong with the microphone there.
I don't know. It's not me anyway. Can you
No,
hear me?
no, it's okay. It doesn't matter who it is. Just,
And Andrew's image is flicking on as well.
sorry?
You can see Andrew.
Is he all right?
I think somebody needs to mute microphone.
All right.
I think somebody not muted microphone and it's too much distortion.
Yeah. Well, just mute your microphone for while I'm talking. When you want to talk to me, just unmute it. All right. It's just sometimes the microphones just pick up extra shit. Okay. And if you want to mute it, all you have to do is just, so I'm going to mute mine. And now it's unmuted.
Will they be separate files?
What?
Message from Andrew.
Oh yes, they're separate files. Okay. So we have Andy has its own file. We have Helen has its own file. We have Sean has its own file. We have Siobhan has its own file. Now, however, if we run any of these commands again, it's going to create another file. So let's say, so my human is just to say who each one of them are. This is Andy. This is Helen. This is Sean. This is Siobhan. Okay. Now, if I run any of these commands again, so if I run the Andy one again, so you can see I've only got one file for Andy. If I run it a second time, and I refresh here, we can see I now have 2 files for Andy. All right. Now, I only want 1 file for each one of them. So what I'm going to do is I'm going to delete these 5. Gone. And I'm going to run all 4 of them again, just once. So that is Sean, Andy. That is Helen. That is Sean. That is Siobhan. Okay. To prove that it is, I'm going to refresh. They're there. Andy, Helen, Sean, and Siobhan. Is that okay with everyone? Yes?
Yes.
Yeah.
Yeah. So I will comment out that guy, comment out that guy, comment out that guy, comment out that guy. Okay. So each time you run this command, we create a new serialized file. Okay. So if you run my serialized human, my human, that's going to create 20 files for Andy. All right. Everyone with me so far, yeah?
Yeah.
Yeah. Okay.
Why 20?
Well, if I ran it 20 times, you're going to have 20
Okay, yeah.
files. Simple as
Yeah.
that.
20
Okay?
copies then, yeah.
Exactly.
Yes,
Okay.
it's exactly called.
Yeah. So, and by the way, I want to print off the file name here as well. So I should have done this. I need to run this again. Now, the reason I want to print off the file name is because I want to use that to deserialize the file. So again, I'm going to select each one of them. So 3 of them have gone. Now I'm going to run them just once. All right, so run it just once. And I don't need the nanoseconds. I just want the file name. So there's our 3 files. Andy 239, Helen 331, Sean 330, Siobhan 334. All right, so I'm going to refresh that. And there's our 4 files. So, and what I'll do is, the simplest thing is I'm going to save those to a notepad. All right, so I have another file here, another notepad file. Now, ideally, you'd want to be saving these to some sort of list or set. Actually, save them to a set. As you create them, you save them to a set. You can make that set static. All right. In actual fact, that's what I'll do. I'll create static string or static file. That's going to be a list of file objects, and that's going to say my files. So import that guy, import that guy. Import java.io. Okay, so static list file my files. So I'm going to say is equal, or make it a set actually. Static set file files. I need to import that. Import set is equal to new hash set. Import that, import hash set. So again, I'm going to delete them again. So as we're going along, I'm going to be adding these file names to each one of these guys. So I'm going to, so as I create the file names, I'm going to go files.add new file, and I'm going to say file name. All right, so I'm going to try it again. All right. So I refresh here. All right, so there's our different, if I go here, so if I go, okay, it's not taking it because it's not fucking on. All right. Now, I'd have to run it again for this to be populated, all right? But if we run it, we create our 4 files, this is going to be populated with each of our 4 files. Yes, does everyone understand that? Yeah?
Mm.
Okay, right. Now, so we have our 4 serialized files, all right? I fucking have to run it again. It's all right, I have to run it again. So I'll get rid of the 4 of them. Okay, so I'll run it just once. Right. So I'll save them to a Word file. Now, ideally, I should really be saving them to another file, but we won't bother doing that for now. So I'm going to put it here in a Word file. So there's 4 of them. I could write them to a file as well, but I don't want to make things any more complicated. All right, so I have my 4 file names saved. All right, so now I'm going to do that guy, that guy, that guy, and that guy. Okay, so I'm going to refresh, and yep, there are 4 files. Okay, now we're going to create another method to deserialize. So it's going to be a simple deserialize. So serializing is not the problem. The problem is deserializing and making sure that you're deserializing the correct file. All right. So serializing is easy. It's deserializing that's the problem. So we are going to create a deserialize method. So static. It's going to return a human. Okay. And it's going to be called deserialize. So it's deserialize. Okay. Now, what it's going to take is it's going to take, just to keep it the same here. Okay, so it can take a string or it can take a file object. It's up to ourselves, whichever one we want to do. Okay, so we're going to use these strings. Okay, we're going to use these strings. So we're going to, it's going to take a string. It's going to be called file name. Okay, put down here, return null. Now, so we have to create a human inside here. Human, my human. Okay, so what's this guy? This will be the human. This will be the human created when we deserialize our file. Okay. Now, so whereas this guy here is using file outputs. So when you're creating your files, you're using outputs. When you're creating your class, when you're creating your object from a file, you use inputs, which is these guys. So I'm just going to copy and paste it. So I'm using trial resources. You don't have to bother with closing or flushing or any of that shit. Okay. So go here. We have catch exception. E. Okay, so import this guy. Take this guy in. Now, so file input stream, blah, blah, blah. Okay, so we're going to go inside here. My human is equal to, we go in dot read object. Okay, in the read object. Now, that is an object reference to a human object. So we can cast it to be a human. Okay, and then we can return my human. So return my human. Hold on a minute. Why isn't that? Oops, sorry. All right. So now, so what we're going to do is we're going to see so this one here is ending. Yeah. We're going to see, does it deserialize ended properly? All right. So we are going to go here, print off. So it's going to be deserialize in, and I'm going to put in, that is, not just going to check my Word file here. Yep, they match. So this is the one we're going to use. Nice. And And that is, so it takes a string. Now, so I'm going to go, this should print off all the details of Andy, okay, which is the same as this guy here. So this guy and this guy should match. Yes? Does everyone understand that? Yeah?
Yeah.
Yeah? So deserialized human returns a human. Now it returns a copy of this guy. So if I print off my human, it should be the same one. Well, there they are. Okay. Now we'll just assign this to another one to make things easier. Okay. So I'm going to call this human, new human is equal to deserialize, and I print out the new human. Right. So now I have an equals to method inside here. All right. Now if I go here, I go my human dot equals new human. Now I have set up the equals method that if they have the same name, age, and weight, it's going to return true. Does everyone understand that? Yes?
Yes.
Yeah? Okay. Now, I have overridden the equals. So I've overridden the equals method. That means now I've let Eclipse do it for me. So that means if they have the same name, if they're the same age, name, weight, and job, they're going to be the same. Yeah? Yes?
Yeah. Yes.
Right. Now, so now we are going to use hash code to uniquely identify an object. Now, as you can see, hash code does not uniquely identify an object in this case, because my human and new human are two different objects. But the way we have written the equals method, if they have the same name, age, weight, and job, they're going to be said to be the same. Yes?
Yeah.
Okay, right. Now, so what you usually have when you're deserializing is you have some sort of check. Okay, is you have some sort of check. So what I'm going to have here is int code or int check. All right. Now, so it will only deserialize the file if it has the right number. Now, in this case, we're going to say it is the hash code. Okay, it is the hash code. So now just to comment out this guy for a minute. All right, and comment out that guy and comment out that guy. So if I get the hash code for Andy, okay, that's the hash code for Andy. Now never mind that it's minus, that doesn't matter. Okay, now if I just take off the check here for a minute, don't want that there, and I put everything back to the way it was. Okay, and if I go new human.hashcode, the two of them should match. They both have the same hash code. All right. So what we're doing here is we're using the hash code to uniquely identify an object. Now that depends on how you override your hash code method. In this case, we have let Eclipse do it for us. So if they have the same age, name, weight, and job, we're going to say they're the same. All right. Now the problem with that is you can have two humans with the same age, with the same name, with the same weight, and the same job. You can't differentiate between the two of them. But we'll get over that in a minute. Now, so we're using the hash code to uniquely identify an object. All right. And we're using the hash code to tell this method here whether to deserialize the class or not. I'll show you. It's pretty simple. It's just a series of if statements. All right, so it's going to pass an int check, which is going to be the hash code. All right. Now we still go human, my human, and we go my human in dot read object. Okay, so we would go if check is the same as my human dot hash code, return my human. Okay, otherwise it's going to return null. All right, so if the number sent to this method is hash code of the human object we wish to deserialize, then return that human. Otherwise, null will be returned. Okay. So otherwise, no, I'll just show you how it works. So we are going, so human, new human is equal to deserialize end. So we have to get the hash code of this dude here. So my human dot hash code, I quite simply go here. I go int code is equal to my human dot hash code. Okay, so we're going to pass it the file, and we're going to pass it, I'll actually call it the same name, check. Okay, so we'll see, does it return the new human? Yeah. Okay, so what is this here? So if this is correct hash code for, if this is the correct number for this version of Andy, the file will create a deserialized object. Okay, so that creates the correct object. Now, if we send us the wrong type, so we're going to redefine human equal to, so I send it that. And we send it the wrong number, number 12. Okay. And if I go to print off new human now, we get null. Okay. So when you're deserializing, what you need is some form of check to uniquely identify the file to make sure it's the right file. Now, the beauty of the hash code is, so does everyone understand that so far? Yes?
Yes.
Any questions? Any questions?
No, just no.
No, okay, right. Now, so this will deserialize. Okay, because check is the hash code, is the correct hash code for this file. Now, if we come along and we change the hash code for this human. Now, how do we change the hash code? So this guy up here. So my human is Andy. Andy. So what we're going to do is we're going to change the name or the age of Andy. All right. Now that means that the hash code is now different. Okay. So check is equal to my human dot hash code. So now if I do the same thing again here, and we're going to pass it in check. And if I go to print off new human here, we get null. So if we change any variables of the particular human, you can't deserialize them. That's the way deserializing works. So you always, when you're deserializing, you need to put in some sort of check. Serializing is fine, no problem. It's deserializing that is the problem. Another way of a check would be if you timestamped the file. All right, as you said, Igor, earlier on, you put in the full time plus the date. Okay, so another check would be timestamp the file. Now you could have the timestamp inside the object itself. So each time you deserialize, it's going to check the timestamp of the file. It wouldn't make sense to have the name as the timestamp, because then a hacker would know what the timestamp is. So the check can be anything you want it to be. Now here in this case, it's a hash code. Now hash codes can be difficult enough to use when you're serializing, because you have to make sure everything else inside the hash code is also can be serialized. If not, you're going to get different results. Also, you have to make sure that your hash code is not using any statics, or you don't have any transients. So when you're deserializing a file, you should always put in a check to make sure that you're deserializing the correct file. Any questions on that? Any questions?
Not a question, but kind of remark.
Yeah.
So you hard coding the name.
Yeah, I'm hard coding the name in this place. You wouldn't normally do that, Igor.
Yes.
You'd have the names of the files saved in another file or in a database.
I know this maybe beyond the scope of this lesson, but how would you do it?
How
my machine
how would you say the name?
dynamically identify the file name you want to deserialize?
Well, what you're doing, Igor, is you're uniquely identifying the object, right? And you're so there is some number being generated from this guy up here, okay? And when you deserialize, so you serialize ending, all right? When you deserialize ending, it should be the same. Do you understand me?
Yes, yeah. So based on the hash code.
Yeah. Well, in one sense, yeah. But hash codes are can be difficult enough to code. All right. Yeah. I have another one here done with, and I haven't fully. It's kind of complicated, to say the least.
Yes, I understand.
I want to make sure I know it fully myself before I show it to you.
Yes.
It uses statics instead. Now, if you use statics, it's actually easier, believe it or not.
Yeah.
Yeah, so hash codes is just very complicated, and a lot of things can go wrong with hash codes. All right, so it'll be after lunch before I show you the statics. It might be,
Yeah,
it might
sure.
be tomorrow before I can show you the statics version. Okay?
Yeah, I understand.
Yeah. Now, as far as I know, this particular thing is not on the exam. However, if you are using serialized files in the real world, you have to do something like this.
Yeah.
Okay? You have to have some sort of, so serializing is easy, deserializing is the problem.
Yes, I understand.
Okay?
Andrew is trying to say something.
Okay,
But
Andrew.
we don't hear him.
We can't hear you, Andrew. Could you type out the question, Andrew? I can't hear you, Andrew. Can you hear me? Can everyone else hear me?
Yep.
Yeah, sure.
Yeah.
Sorry for shouting there. I'd say you could hear me.
What?
Shut up, mate. You can hear me.
I put my gramophone on.
Okay.
Sorry, no, just before we move on there, no, sorry. Why is it that we don't have to override the equals? I thought we had to.
We have overwritten the equals.
Sorry?
We have overwritten the equals method.
Oh, we did we? I thought it was just
And
hash code.
human
Okay.
.java.
Yeah.
Ah, okay, gotcha. Good.
Hello?
Cool.
Yeah, yes, Kathy, go on. Yeah, Kathy, go on. Yes, Kathy, have you a question? Hello? Can you all hear me?
Yeah, we can hear you.
Yes, sure.
Okay.
Yes.
All right.
Yeah.
Yeah, I think she was just saying that we have overridden the equals. Yeah.
Yeah, we have. Yeah. Okay. That's good stuff. All right. So I should have put this in here. So we have overridden the equals and hash code method of the human file. Okay. Now we've overridden the equals and the hash code method of the human file. So that's it's using the hash code to uniquely identify the object. Using the hash code method. Each human and each file. Now, as I said, using hash codes, it can get very, very complicated very, very quickly, particularly with something that's got numerous values in it or has got sets inside it. And you have to make sure that each object inside this set is implement serializable as well. And so I have another example here. The problem with the example I'm running on the other machine is that it's producing two different numbers, and I can't see why it's producing two different numbers. So I just need to double check it. All right. But statics are easier to do when you're using deserialization than hash code. All right. Now, that's 8.3D.
There's a question from Andrew in the chat.
Okay. Yeah, you would, Andrew. Yes, you'd write it to a database. Yeah, exactly. Okay. Now, you'd only write it to a database. You wouldn't write it to the database straight away. You'd write it to an array list or a set or a hash map or something temporarily. And maybe at the end, when you shut down your app, it will be saved to your database, right? So you don't save everything straight away to a file. You don't have to, because reading and writing is just slow things down. Okay? You can, if it's something important, you can write it straight away, but you don't have to. You usually save it to somewhere intermediate, like a set or a map or whatever. Is that okay, Andrew? Yes, Andrew. Okay, is the answer. Right, now, so we are going to do, so we have done our three different types. So the first one was input and output streams. Then we have readers and writers. Then we have object input and object output streams. Okay, so now there is a fourth type. So let me just see if I have it here. So it is this one, I think. So 8.3. So just give me a second here. All right, so it's not that one. 8.3. So just a second.
Who's whistling?
That's me. That's me. That's me. That's me. And okay, so 8.3. So just give me a second here. Get the right one done.
Hold on to the day job.
Ah, I know, Kieran. Thanks. So it's 8 point. So that is 8.8b. So just bear with me a minute here. I have a load of files here. So 8.3b is chapter 8b. This one. Okay. D D D D D D D D D D. Okay, so now these ones really aren't used all that much, okay, but I'll use them anyway. All right, so this is 8.3 BCDE. So new class. So it's, oops. So new per Java project F8.3 ABCDE. And this is working with streams. Finish. So go here. So this one here, we are going to do here. So so we have a new class. So I've got new package com.android. I go new class main public static void main finish. Then we have new class examples. And then finally we have animal. Okay, so I'm not going to bother with animal, I don't need it. All right, so these ones are going to be something called print stream and print writer. High level classes that write formatted representations objects to a file. Okay, now so this isn't serialization. This is taking an object and writing something about this class. Or so let's say it's taking an animal object, that's what we're going to be using, and it's going to write all the details of the animal object to a file. Now it's going to be in readable. Now it's going to be in human readable format. Now serialization is it saves noughts and ones. This saves text. That's the difference. All right. So print string and print writer are high-level classes that write formatted representations of objects to a file, i.e., clear text of a animal object would be animal name equal to Andy, age equal to 45, and weight equal to 45.6. All right, so it's written in clear text. Okay, so print stream works on output streams and writes data as bytes. Print writer works on writer objects and writes data as characters. Okay, so it just writes plain text to a file. So it takes in a class, takes in an object, in this case is going to be animals, and it's going to write out the information. Okay. All right. So I am going to create a file inside here. Okay, so I'm going to go new, and this is going to be a text file. So the first text file I'm going to create is going to be called rubbish.txt. Okay. Now, so there's nothing in it at the moment, right? So it's very easy to print something to these sort of files. So I am going to go, so I'm going to go static void ex1. Okay, so that's what so print. So print is the most basic method of a print writer object. Okay, so print is the most basic method of a print writer object. And it basically writes to file. Okay, now, so try. I'm going to print writer out is equal to new print writer. So our file is called rubbish.txt. So I need to import these guys. So this is our try resources. All right, so now, so we're going to write just some bullshit to it. Okay, so I'm going to go out dot print. So I'm going to write 5. Now what this does is it actually writes the number. So I'm going to run this. This from name. All right, go to rubbish. Now it's a bit of a, what's the word? It's a print actually writes it to a file. I don't know why the hell would like that, but that's what it does. Okay, so you create something called a print writer object. This is for writing to your file. Now the print method of the print writer object writes the number 5 to the object. Okay. Now, if so just a second, I have to go. Give me a minute, second now. Now, that puts in another 5. Fucking hell, just give me a minute here now. Now, this writes, now, this is where it starts to get a bit complicated. Okay, so this will write 5. Okay. Now, string value of 5. These basically do the same thing. Okay. Now, if you want to write, so print quite simply writes it to the file, which is kind of funny. If you want to use write to put something into a file, you have to use that syntax. Because what it's doing is, a text file can only take strings. Okay, if you're using the write method, it can only take strings. If I do this, now that should be written to. Let me just see. Go here. See what happened there? The second thing there is a question mark because it doesn't know what it is. Because when you have a print writer object, a print writer object can only write characters or strings. All right, it can only write characters or strings. Can't write anything else. So if you want to write a print writer object, can only take strings or characters. So if you want to use the write method, this can only take a string or a character. Okay, it cannot. If you attempt to use a int with a write, it will not recognize. So what you need to do first is you need to use this guy, string value of 5.
You put inverted commas beside and
No, because inverted commas is only for strings. Single commas.
You're just missing your.
Yeah, sorry.
Sorry, no, you're just missing your string there. This only takes in your description there.
A printer can only
A
take
string.
strings or characters. So if you want to use the write method, this can only take a. Thanks, Iggy. This can only
No
take
bother.
or a character. All right. Yeah. Now these print writers and they're bullshit. Okay. Pure bullshit. That's the best way to describe them. But we have to cover them anyway. Now, I'm going to quickly create an animal class. I'm going to quickly create an animal class. Now, I'm going to go on for a bit longer because I started late today. So, I'm going to go into age. I'm going to go string name. I'm going to have a basic constructor that takes in an int and an age, string and a name. And this dot age is equal to age. This dot name is equal to name. And I'll just generate a toString method, source, generate toString. Right. Now, so what I'm going to do is I am going to write an animal to it. All right. So I am going to create a animal inside here. So I'm going to create animal md is equal to new animal. So animal takes an age and a name. So I'm going to give him an age 34 and a name of md. Now I can go out dot print. What I'm going to do, I'm going to write md to this. Okay. Now we have a look at it. We have a look at the animal, or we have a look at rubbish. See what it does? It writes the toString. It takes the toString method, and it writes that to the file. So I'm going to change that to be a little bit different. What I'm going to do is I'm going to put in what's the escape character for a new line? Does anyone know? Does anyone know the escape character for a new line?
\n.
Backslash n.
Backslash in, yeah?
And yeah.
Yeah.
Okay, so I'll have a look at this guy. Yeah, there it is. All right. So here we're writing to, so I'm going to change that again. So I'll say animal age is, name is. All right. So what does this guy do? This takes the toString method of the animal class, and whatever the toString method returns is what will be put in the file. Simple as that. Now, it doesn't work. Okay, so out.print md, that's going to put md to the end of the file. You can also go out.print. I create a new animal. I'm going to call this animal Angela, or sorry, going to be an age of 12, and this animal is going to be called Angela. All right, we have a look at rubbish.txt. Age is 12, name is Angela. So all print writers really are about, it saves your objects to a file as written text. Serializing is saving your objects as not bytes, not to ones. Whereas a print writer saves your object to an external file as written text. So does everyone see the difference? Yeah?
Yes.
Okay. Now print and write basically do the same thing when you're talking about print writers. All right. Now, but writers are always a lot more complicated. So if I want to write to a file, this in here. So we're seeing up here, you can only take strings. So if I want to use the write method rather than print. Now, why you'd want, I'm sure there's some valid reason for using it, but I don't know. So if I go out.write, I'm going to just create a new animal here. So I'm going to write ND to it again. All right, so write. If you just do that, that doesn't work. All right, because you have to check for nulls. All right, or even if I go nd.toString. Now that might work. Let me just see. Okay, that does work. All right, so that's one way of it working. Another way of it working is this way. Right. So this is checking to see if ND is null. So ND null, the ternary operator. So if it's null, we're going to return null. Otherwise, we're going to put in nd.toString. Okay, so that will also write ND to it. Okay, but we need to check if ND is null. So let's, if I change ND to null, ND is equal to null. It doesn't write, it writes in null. Okay. Any questions on that? Now, do you know what? I might as well take the break now. I was going to do another 15 minutes, but I'm just going to go over and make sure I knew everything about the inputting and outputting stuff. So I'll see you back here in an hour around 1:30. Is that okay with everyone?
All right, Jack.
Yeah.
Yeah,
Thanks.
that's
No, thank you.
So I'll see you. So what I'll do is I will just pause the share. Oh, fuck it, I didn't record it. Oh,
Ah,
No.
you
It's
did.
you did it.
You did.
did I?
Yeah.
Yeah.
It's flashing recording.
Is it?
Yeah.
No.
It's,
Oh, it is too. Oh, it is too. Oh,
yeah. It's top of the screen. Yeah.